two triangles are similar. Triangle A is 90 degrees and 44 degrees for angle B. DEF is 90, so they have A and D in common, and 90 minus 46 is 44. So if angle B is 44, angle F must be 44, so they must be similar. In the second problem, A is 132 degrees, B is 24, D is 90, F is 24. So even though F is 24 and B is 24, since this is 90, so D is 90, E is not going to be 132. You're going to have more than 180 degrees there, so they are not similar. And now we're going to solve this. 6 times 8 is 48. What you want to remember here is you have to distribute. So 12 times x is 12x, but 12 times -1 is -12. Add 12 to both sides. You get 60 equals 12x. So x is equal to 5. Congruent corresponding angles to show that two triangles are similar, you can also use proportional corresponding side lengths. So in the side congruence theorem, we said that the relationship between the sides had to be equal. In corresponding side lengths of two triangles are proportional, then they are similar. So if the relationship to AB to RS is the same as the relationship of side BC to ST, and CA to TR, then they're going to be similar. So we're going to use this. So for instance, here they want to see if they're similar. So they say compare them by finding the ratio. So if you look at AB to DE, 8 to 6, and they've kind of color-coded you to see which sides you should check here. We're going to see it later on, but if you're not sure, I would say pick the larger of the two, the largest, then the middle ones, then the smallest ones. But 8 to 6, in this case, they picked the smallest sides, is 4 to 3. Okay? And on the next side, so 12 to 9 would be 4 to 3, 16 to 12, both divisible by 4, you get 4 to 3. So ABC and DEF are similar. Now let's compare 12 to 10 is a ratio of 6 to 5. So the next one, 16 and 16, is not a ratio of 6 to 5. So ABC is similar to DEF, but it is not similar to HJG. And if you want, there is the written out explanations. Now let's also use the similarity theorem to find missing values that make these true. So find the lengths of x that make the corresponding side lengths proportional. So they've told you what you're checking. So here BC needs to be similar to EF. So 4 over 12 needs to be similar to x minus 1 over 18. Like we did in the first lesson, in the warm-up, we're going to solve, and we get 7 is equal to x. And you can go back and double check. I think there was another one. So 7 plus 1 is 8 times 3 is 24. And you can see that 4 over 12 is proportional to 8 over 24, and this would have been 6 to 18. Side here is 20. The smallest side here is 24. They're both divisible by 4. That's a ratio of 5 to 6. The next side is 24. And the next side here in length is 30. Okay? These do not have a 5 to 6 relationship. So LMN and RST are not similar. Let's try a different color here. LMN and XYZ. So the smallest side here is 20. The largest side is 30. That's 2 to 3. Then the next side is 24. And the next side here is 36. That's also 2 to 3. The largest side is 26 to 36. That is, sorry, to 39. But 26 okay. Divided by 13 is 3, and 26 divided by 13 is 2. So triangle LMN is similar to triangle YZX. They listed differently, MLN, so ZYX, but as long as they line up, that is correct. And for guided practice number 2, they tell us that the shortest side of a similar triangle to RST is 12 units long. So since RST is 24, half of 24 is 12. So on this side, the similar side, half of 30 is going to be 15, and half of 33 is going to 16.5. So it's time for Theorem 6.3. The number doesn't matter though, the side-angle-side similarity theorem. But you can kind of assume at this point what this theorem is going to say. But if an angle on one triangle is congruent to an angle on a second triangle, and the lengths of the sides, including these angles, are proportional, then the triangles are similar. So you are building a lean-to shelter starting from a tree branch as shown. Can you construct the right end so that it is similar to the left end using the angle, measure, and length shown below? So since these are both 53 degrees, and 6 to 9 has a ratio of 2 to 3, 10 to 15 has a ratio of 2 to 3. They're going to be similar. Okay. So the lengths of the sides that include angle A and angle F are similar. You see that here. So we have learned angle-angle similarity postulate, side-side-side similarity postulate, and side angle side similarity postulate. Now we're going to get to choose a method. Tell what method you would use to show that the triangles are similar. So for this one, you could see that 9 to 15 is a ratio of 3 to 5, as is 18 to 30. These two angles are going to be the same by vertical angle congruence theorem, so you can use side angle side to show that these are similar. Now you would need to be able to show and by which method you're using. So right here I have two sides and an included angle. I'm going to try and use side angle side. The included angles are similar since they're both 90 degrees. 24 and 18 are both divisible by 6. 24 divided by 6 is 4, and 18 divided by 6 is 3. So let's look at the other two sides. 28 and 21 are both divisible by 7, so that's 4 to 3. So the triangles are similar by side angle side. The proportion of the corresponding sides is 4 over 3, and the angles are congruent. Now they want us to explain. So for problem number 4, I have a bunch of sides here, and I could look at this a few different ways. They want to show x, z, w. So x, z, w to y, z, x. So side xz is 12, side yz is 9. That is a ratio. They're both divisible by 3 over 3. Then they want to compare side ZW, which is 16, to side ZX, which is 12. Once again, that's a ratio of 4 to 3. So it's important to look at what they're comparing to what, because what they're actually doing here, let me try and draw this so you can see this, WZX, okay? They're not just taking this side and comparing it, they're actually taking this and rotating it so that you have Z, Y, your Z is here, your Y is here, and your W is here. So they're actually taking this and turning it sideways, almost rotating this Z down to point W. These are congruent by side, angle, side. It looks like side, the right angle. But we could take that last side there, which is y to x, 15, corresponds with x to w, 20, and see that also is 4/3. So we can show that these are similar by either side, angle, side, using that 90 degree, or side, side, side. But it is very important to pay attention to what sides they're showing are congruent, because if you were to just look at this and just assume, oh, 12 and 12, that's the same, like reflexive property of congruence, which is what we would have used in triangle congruence, is not something that we would use here. So they want us to verify that triangle ABC is similar to triangle DEF for the given information. So they're telling us that AC is 6, DF is 6. So that's a ratio of 3 to 1. AB to DE is a ratio of 3 to 1. And BC to EF is a ratio of 3 to 1. So they are similar, and that is the side-side-side similarity theorem. Okay, and for problem number 2, show the triangles are similar and write a similarity statement. So I have a side, angle, and a side. I can see that that included angle is congruent. 30 over 40, that's a ratio of 3 to 4. 45 over 60, they're both divisible by 15. That's a ratio of 3 to 4. So they are congruent. We have side, angle, side, and it's x, y, z, triangle x, y, z, is similar to triangle A, B, C. Okay? And so that you can go through, here's your homework problems so that you can do your homework.